Hello YouTube, RJ. Well, in the last video, we soldered up the voltage reference, which I'm calling the DMMR, Digital Multimeter Reference 1. And I'm going to do this video kind of backwards, actually. I found these little inexpensive boxes on Amazon. They're electronic boxes, but they pop open, they snap shut. So let's take a look at what I've done, okay? So we've just got a plastic box, inexpensive one at that. And this is what I meant by we would mount the board actually using our post. So the post actually, these are also off of Amazon. They have their fixed spacing. Okay, so I went ahead and what I did was I bought the box, and then I used the laser. Of course, you could drill this, but you tend to use what tools you have. Not everybody has a laser cutter, etcher, engraver. But if you could mark out and drill the holes, it was just easier for me to cut out exactly the size I want. It's more precise. It just cuts the hole out for me. So that's what I did. I cut a hole in the lid of the box, and the post go through and literally clamp down with two nuts to the board. So there's a washer under, there's a washer on top, and double nutted. So we've got nice secure support of the board. You can see we've got our two batteries in. You can see here's our reference chip, and here are the two precision resistors I was talking about earlier. Let me do this. Let me bring the camera down a little bit for now, and don't mind. Sorry about moving you around so much, but that'll give you a little better view. Excuse the wobble. Okay, now what you've got is you've got your voltage reference chip here. This is R1 and R2 that I discussed in the previous video. And what I was trying to say, I don't know how clear I was, is these are very precision resistors. I'm trying to remember, I think they're 0.1% surface mount resistors. This one is, as I remember, a 5K precise, and this is a, no, I'm sorry, 1K, and this one is a 5K. Now that means that when you go from your common to this point, your 5,000 ohm section, you're just measuring this precision resistor here. When you go from the 5-volt output to common, you're measuring 5 volts coming straight out of the reference chip to the post. And then if you connect your milliamp, you move your probe to milliamp and connect to this one to common, because we're running this precision resistor, we have a precision 5 volts through a precision resistor, Ohm law applies, and therefore we come out with 5 milliamps precision. The button just literally connects the battery feed to the circuit, so the batteries are out of the circuit whenever you're not pushing the button. Now some people are going to say, well, it's not a very good precision. You want this thing to be on all the time, warming up and staying at the same temperature. Well, that's true when you're working with lab level instrumentation, but the truth is, if you look at the specs of this chip, at the current that we're drawing through it, you're not going to make a big difference, especially in the short time we're going to have it on. It's not going to warm up much. You're not going to have a big variation, and we are not going for 0.1 ppm here. This is not what this device is. This is a good enough for our meters to make sure things look right. The precision of this will be far over, for example, my Owen meter that we're going to use here in a minute to check this thing out. But the nice part is once you're done, you just literally snap the box close and you're good. Now, what I'm going to do is we're going to test it on the meter and see how it works. And then I'm going to cut then to those who are interested in how I silkscreen this and other things. I've done my home-built, self-designed ham radio equipment and amplifiers, and I mean I've silkscreened airplane dashes for the airplanes. So I've done this a lot, and I'm going to talk a little about it for those that are interested in silkscreening and how I do this. And as you can see, it makes it for a very nice text and such on your projects. So give me a second to move the camera back, set up a little, and we'll test this out and see what we think of it, okay? Okay, I'm back, and hopefully you can, I've had to turn some lights off because of glare, but hopefully you can see, and I'm trying to get this all in one shot for you here. So what we're going to do is we're going to go ahead and hook our meter up. And since I've got the probes connected, the easy way to do it is put it in the hole of the terminal and tighten her down. And now I've got a good connection. And let's start out. I'm on volts with my Owen meter here. So let's hook it up to the 5-volt section. Push the button, and we're getting 5.0008. So very happy with that. I would say pretty accurate. So now what we want to do is we want to let's do the ohms first before I have to move the probes. Let's go over here, connect to our 5,000 ohm terminal. Let's change the meter over to ohms. Let's take it off auto range, 5,000 ohms. And I probably should have done this first. Let me take these out. Let me zero. Settle a minute. Okay, turn relative on to get get it pretty well down there. So let's put in our probes into the resistance position. And we don't have to push the button for that because you're just going across the resistor. But as you can see, it's 5.00042, 3. So I would say the meter's pretty close, well within the variations of, what our resistor precision is. So now let's check milliamps. So let's move our probe from here to the milliamps position. And the nice part about using these connectors is if you've got banana jack plugs, you just plug them in the top. You don't have to do this. I'm doing it because I'm using these probes, and I want to make sure I got a good connection. So let's take and move our probes over to milliamp. Let's go to milliamp. Let's put the range on 50 milliamp. Okay. So there we are. Let's push our button, see what we get. I have my meter on slow. If I turn it off, let's put it on high speed where it changes quicker than average. Pretty close. Let's go and let's change the speed back to low. 4.982. 4.982, around 4.9882, somewhere around there. That's pretty close. Not perfect, pretty close, but I'm pretty happy with that. So I would say we've got a success here. So the next thing we're going to do is I'm going to cut over, set up, and we'll do a video where I'll talk through me silk screening these boxes. So hang in there. Okay, so this is the product that I use. It's called the EZ Screen Silk Screen Stencil. If you Google on the internet, you'll find it. It's not hard to find. They sell kits to do this, both small and large size. And what you get is everything, including the instructions of exactly how to create these silk screens and do what I do. Use this on everything, on my ham radios and everything. This is the black bag that'll have the actual silk screen, coated silk screen in it. It's you got to keep it in the dark. It's light sensitive, so only take it out in a dark room. You don't have to be totally pitch black dark, but just no sunlight or no real bright lights for any period of time. And then what you do is you design your artwork, and I use this laser printer transparency film because I'm using a laser printer. You can do it on inkjet too. They prefer laser, but you print your artwork once you've got it done and sized properly and you're happy with it. You print it on this clear transparency film, and here is the transparency film for the here, get something white where you can see it. Here's my mask for our little voltage reference. And you can see what's on the box is what's here. And then once you've got this artwork where you want it, what happens is you use that to keep light from hitting this material. The material will harden if sunlight gets on it. So when you put this over it and put it out in the sun, what happens is where the mask is dark, that will stay unhardened and the rest of it will harden. And so, once you lay it up there and do that, then you wash it and it washes it out of the little screen. You lay it up like this, and then the sun will be blocked out where the print is. Sunlight will harden everything else, and you can rinse it out. And what it is, it's a little screen. I use the high def. They have different 2 levels. High def is it does a little better fine print, so I do high def. Then you put it back in the sun once it dries after you've washed all of it out of your printing, and it hardens up really hard and makes it quite durable. It's pretty tough at that point. So you're ready to go then. This is what's going to allow ink to come through, is through that fine mesh. You can't really see the mesh on the camera here, but this is for the smaller size. And this device, you put your material down, then you put your mask over, and you clamp the acrylic over the top to keep it all pushed together, and you put it in the sunlight, and voila, it hardens. It takes about like a minute or so out in the sun. So that's the small one for this smaller ones. And then I also use the 8.5, the full size, for bigger projects. Okay, here's the ink that I use. It's called Jacquard Professional Quality Ink, number 119, super opaque white. You can see their website there, jacquardproducts.com. This works on everything. I mean, they make this that goes on like t-shirts and stuff, but this is for, and I'll turn it here and it'll say this in a minute, but in the instruction, you can probably read it here. It says, this is a professional screen printing ink for all surfaces, art prints, will not wrinkle paper. I haven't found anything it won't work on. It'll work on plastics, metal, I think it'll even do on glass. It's a permanent ink, so works good. I've used it on my ham radios. I use it on everything. This is everything that I screen print. So here we are. We're going to screen print now. What I do is in this case, I use some circuit boards. They were about the thickness of the covers of the case, and so that allows me to line up the silk screen level all the way across. Got to clean it really good. I use 99% alcohol, 99.9 actually alcohol, and I clean the box tops or whatever I'm going to silk screen. And then what we're going to do is we're going to lift up our silk and slide it in there. That'll line it all up repeatedly, and lay the silk screen smoothly down. And I'm going to try to tape it here, but that's not going to work too good for me, so it just gives me a handle to lift it up. But get a little on there, wipe it right back off quickly before it dries. You can take alcohol and clean it right off till it dries. So now I'm going to take my squeegee, got a little ink on it, and I'm going to just drag at a high angle across it like this. And what that's doing is I've already pre-charged my silk screen with ink to start out with. That's what the paper was originally. Put a piece of paper down, swipe over it till it starts getting on the paper. And so that's pushed it through the silk screen, as you can see, and it has silk screen that top now, because I've got it all set up, almost like I don't know what you'd call it, a stencil or whatever. I slide it right back in, put this one down, maybe add a little bit more ink. Usually, you want to make sure you got enough ink on there. See, I'm sitting here thinking, probably ought to put a little bit more down. So I'll just drag a little fine line more to make sure that I have enough. And I'm going to do it again. As you see, the trick is to lay it down at an angle so that you're pushing it down through, and make a swipe across and pick it straight up. hinge it on the tape at the top, and slide it out. And it's that simple. I just stenciled 2 of them. You got to put paper down because otherwise ink's going to get on. And that's all it is. So see how thick this stuff is? I'll swipe it back in there. Start cleaning up. And you've stenciled. Now it's just a matter of cleaning up. You can wash this with water to start with. Scrape off all you can. Wash it with water. And if you have to, you can take a little alcohol and that'll get it off. Just don't let it dry, because once it dries, it doesn't come off. So that's it.